So I think Gary led us into the next one here, Cmm Routine Creation. So we see here we got a graphical format. Anyone can pick it up, off the table, look at it, and get an idea of where these points are. But as the CMM guy, the CMM operator, he can't use this really right into the CMM. So what we do have is we have an export. We have a few different export options. If there's an exact certain type of format that he would like, we do have a few custom exports. And what that can do is it can put all of the coordinates in the first, all of the x coordinates in the first column, y in the second, and we can set that up custom. That way it can be read into your CMM. But we can also export the file, such as a DB2 file in this case. So if I just export this DB2 file, and again, a DB2 file is kind of our file that's easily passed back and forth. Let me go ahead and open that file up just to show you. With the mouse, we have QDM files. We have the top cover here. So what that export is going to look like, just to open a DB2 file for you. So what we have and what we're trying to utilize here is we have X, Y, Z coordinates. We have nominal. We have the lower and upper spec limits, as well as the IJK. This is, again, one format that we can export, but we can have this export into a format in which the CMM guy can use this on his machine. Just by what we've been told, we have some people going through and typing in all these coordinates for their entire part. This one here, I'm just going and going. There's 116 points. So instead of typing in all those XYZs, all of those coordinates, all those IJKs, we've exported into a file here that can be brought into the CMM machine. I'm saying CMM machine, but of course there's other machines that can import this type of file or a similar text format file.
Just for reference, can you define CMM for us?
Coordinate measurement machine in this case.
Yeah. So a CMM, for anyone who might not be aware, CMM is a coordinate measurement machine. So it's a large measurement device that holds a part in place and uses a probe to create accurate measurements of that part using a programmed, what would you call it? Using a program. And what we're saying here is you can use 3DCS to create that program telling the machine where to measure. And one of the reasons that's really important, besides making it easier to create an accurate measurement plan based on critical features you found in 3DCS, is it coordinates your points that you're measuring with your points in your model. So down the line, if you have any issues in production, it makes root cause analysis in your 3DCS model very, very easy, because those points that you're measuring in production are going to match up with your points in your model, making it easy to bring measurement data back into your 3DCS model.
Right.
Yep. And as a side note, Gary Bell here actually did a webinar on that topic not long ago, and I'll include that in the follow-up email tomorrow, a link to that webinar, so you can actually see how what we call closing the loop, where you're able to use measurement data in your 3DCS model. And that's one of the reasons why QDM is so useful here, is because it's a pass-through for 3DCS to connect it to all of those quality programs in production, so that way your 3DCS user can then use measurement data found in production for root cause analysis, problem solving, and continuous improvement.
Right, so not only is this an export for the CMM machine, it's an export that can be possibly brought back into the model. Just to summarize that a little bit. Moving along here, if we're good on the export, we have a plant visibility. Going to go ahead and remove our data set. Actually, I can just start a new one here. go ahead and I'm going to show you. So once you've exported the CMM to the CMM file to the machine, they've checked the part. Now you have a text file of the actual measurement data. So again, I'm going to bring in, instead of my CATIA part here, I actually can just bring in my HSF file that's been converted. So I have my top cover again. I'm going to go ahead and import the data. So this could be like a 20, 30, I think this case we actually have a 25 piece sample, but it can be any quantity sample, such as, even if it's one piece, you can go ahead, start the template, and get the layout and everything in place. So by default, again, I have the measurement plan charts set as my default. But I'm going to go to the QDM software here, and I'm actually going to, let me merge my charts real quick. Going to make these, I'm going to use the comparator chart, and I'm going to show you that here real quick. We have many different chart types in QDM. The comparator here will be our best case scenario. And again, I'm going to go ahead and I'm going to do the same thing in regards to sorting our data. Just going to put 2 charts on a page, and I'm going to do our ergo place, which will lay out the template for us.
So while he's doing this, the concept here is you saw him make a measurement plan. This is QDM Analyst, which is the template creator. Once you create this template, it's fixed, and then you can just populate it with data. So you make a measurement plan, you give it to your supplier, he makes parts and collects data. You also give him this chart, which is what he's going to import his data into, so you can now visually track the capability of the parts. And then if it's bad, you can export it from here and bring it back into 3DCS.
If a supplier already created a CMM routine, is there a way to import those measurement points into 3DCS and QDM?
Yes. Well, one, we have the data grabber that has to be used to get the format, right?
Right,
so
yes.
that we read the form. So we have a tool in QDM that allows us to read any format. That's the power of QDM, which you use that tool one time and then it can always read that data. Now, this is the issue, is if they measured in a different location with a different name, then there's a little bit of exercise that has to happen. You can bring both sets of data into QDM, and you can have points that are from 3DCS model and then more points that are from the measurement plan, which is what we're trying to avoid. There are some functions in QDM that allows you to link points based on proximity. So say in 3DCS you measured, a point that was 1 millimeter from a corner, and the CMM guy measured a point that was 4 millimeters from the corner. If you want to assume that, okay, the variation is going to be the same right there, you can link those 2 points, and then you don't have to, mess with the uncoordinated points.
As a follow-up to that, so on the measurement plan, this is a little bit more in regards to datums. How you define the datums. So this was from a question from a customer that's related to what we're talking about, I think, right now. On the measurement plan, how we define datums from which measurements is a requirement. Different points may have different datums based on functional requirements.
That's correct. And so in 3DCS, we would label those points. You could have datum targets A1 through A4, and then a different datum points F1 through F5. And then you have points that are, measured relative to those datums. We would export the entire data set, all the points, and then the CMM operator would have to parse those out and write a separate program because he's got to set up to the other datum target points on the part. And I see Chris is, when that happens, we actually like to put the GD&T right in the measurement plan which Chris looks like he has up on
Yeah.
the screen right now.
Yep, that's a very common question that was asked there, so I just wanted to pull this up in the background. With QDM, since we can import any 2D images, in this case we have an example where we have a couple datum pages, we have our datum targets, we have the tolerances as well. So what we've done here on this plan is we've actually created one page that has our datum locator points, so that way right away the someone will know which points to locate off of.
And this is where you might have multiple pages. One page showing, the datum locators ABC, another page showing the datum locators DEF, and then your measurement points coinciding with those.
Right, so then in this case we've done it where we got our left cover, our datum points with 25 samples. We can see the trends on each point. Won't go through every single page here, but right cover. So one thing to point out here is we can compare things such as a left hand and right hand to try to figure out how similar they are.
If they're trending.
Yep. So with just going through here, our final gap measures, we saw our assembly had a little bit of variation at that gap. So now we can kind of get an idea if it was this point on this part or if it was the corresponding point on the outside cover part. So this is all a kind of a manual layout that I did in regards to moving which points to which page. So we kind of seen both layouts now where we can go through, sort the report with a couple points on a page, and then we can also go through here manually and decide which points go on which page.
I don't know if Chris had this example up, but because you can load multiple data sets, you can actually create a report that can compare the results from a 3DCS model to the actual measured parts.
Yeah, and
measured assembly.
Yep, that one's coming up. Gary read the future again here.
Oh, excellent.
All right, so with the actual, again, this is just looking at the plant data, 25 pieces. When we have more data, we can either replace this data, we can add it to the end, or we can overlay for comparisons.